con i nostri incontri e siamo particolarmente contenti di avere un ospite eccezionale, che definirei eccezionale qui a Milano, al Wired Fest, per parlare di identità. Abbiamo iniziato il Wired Fest venerdì con un professor Riccardo Zecchina dell'Università Bocconi, un fisico, che ci raccontava come le reti neurali artificiali possono aiutare anche la medicina a comprendere quelli che sono i meccanismi biologici del corpo umano, insomma. E anche per il contrario, riuscire è uno dei più grandi progetti, più importanti progetti in campo scientifico che sta andando avanti da diversi anni e che non ha ancora trovato la sua conclusione, è il tentativo di mappare tutte le connessioni che collegano le varie aree del cervello. Quindi anche le basi biologiche che definiscono la nostra identità non sono così conosciute. È un campo di studi molto interessante che apre degli scenari importanti e fortunatamente abbiamo qui un neuroscienziato dell'Università di California che si è occupato di questi studi, che continua a cercare di capire chi siamo, quali sono le basi biologiche della nostra identità. E quindi è con grande piacere che invito a salire sul palco Michael Gazzaniga.
Thank you. My father's family was from Lombardy, and it's nice to be here and be back. We're going to change the topic and change the message. Let me start things off by reminding everybody what it is we're trying to understand. Could I have the first video? Sound?
It's just some shows that are pretend. And when you explore, you get more imagination than you already had. And when you get more imagination, it makes you want to go deeper in, so you can get more and see beautiful things. Like the path, if it's a path, it could lead you to a beach or something, and it could be beautiful.
So can we lose the music? We got it?
Termites are what motivated this whole project.
Oh, wait a minute.
We learned about these termites.
Okay. The question is, how do we really figure out how we enjoy our conscious experience and develop our self-identity? And when you think on it, how does inanimate life become life? The original activity that is desperately trying to be understood by scientists of all kinds. And how do neurons, which are simple cells, they have no minds, interact in such a way to produce our minds? And finally, how do they wind up and produce what we call our self-identity, who we are and what we are in this world? One of the ways to think about it is that there is a whole science of seeing how small, mindless elements interact in such a way to produce larger wholes. In this particular piece of work, you will see how mindless robots are able to build a larger item, just like ants are easily able to build their castles. And we can show this video, please.
These centimeter-long insects that together build mounds that can be 40 feet or more tall. And we said, that's amazing. That shows that these large numbers of independent agents, all with limited sensing and no central control, that they can together build very large-scale, complicated structures. That's fantastic. Now, how would we do that?
So, how do mindless cells form and give us mind, human mind, as we understand it? Well, this idea of trying to figure this out has been around since modern human history, and let's just take the last 2,500 years. The Egyptians thought 2,500 years ago, all of us were at one with nature. There was only thou, there was no it. So Mother Nature and the individual were all part of one story. And the Greeks came along and said, no, 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 no. There's a brain, it generates the mind, but they also had a spirit or soul in there that with the Greeks at least died when the person died, but in most of Western thought, of course, that's not true. People believe it's sustained. And finally, you get to the people who believe that there's mind and then somehow brain carries out the activities of mind, that mind somehow is in touch with brain. And of course, Descartes came up with that idea 300 years ago, and it's sort of permeated thought in Western culture ever since. We bring up to the modern day, and interestingly enough, we sort of go back to what the Egyptians thought, that instead of humans being at one with nature, the brain is one with mind. The brain makes the mind, and that is the story. Now, since Descartes is the culprit here, the thing he really produced was getting everybody in the scientific community to think that mind was somehow separate from brain, but also that the birth of the machine metaphor, that just as all of biology is a machine, so is the brain. And it's Descartes that produced and generated this idea. So you have in this one slide his major contributions. On the one hand, he thought the mind floating somewhere up here somehow mystically activated the brain through a particular structure called the pineal gland. But he thought the brain itself, as do modern day neuroscientists, think it's quite mechanical. And he called upon Jacques Vaucanson's famous digestive duct, others did after him, to come up with a view that the brain is mechanical, whereas the mind is aloof from the brain. Now, modern thought, modern neuroscience, thinks that the complex brain, with all of its 89 billion neurons, interacts in some sort of way to make it a machine-like, to make it seem that we're all a computer. And this thought makes us believe that we're all determined machines and that we have no free will. We're all kind of zombies working through what's going to happen anyway. This is one of the interpretations that is given this metaphor. Well, the march towards determinism from Copernicus to Newton to Darwin to Einstein and now to modern science has been broad and deep. It's everywhere in our education, and in so much we know that this is true. But what we're really looking at here is the scare that robots, as they become more and more sophisticated, will all of a sudden have one more circuit put in them, one more little computer chip, and they will be free and they will come after us. So here's the question. There's a video here if you can show it. Well, never mind. So when you start talking about us being machines and there's no free will, it gets the attention of various human institutions. The Pontifical Academy of Science in 1962 held a meeting of the leading neuroscientists of the world at the time and said, what's up with this story? We want to understand how brain and consciousness works. And one of the leading scientists at the time, a man named Donald Mackay, a British physicist and neuroscientist, believed, in fact, sort of what the ancients did is that there is only one brain and one mind, but there is also a spirit that leaves the body upon death. Sir John Eccles, the Nobel laureate in neuroscience, believed what Descartes. This is 1962, 300 years later. He believed what Descartes believed and believed that the mind landed on the brain at a different landing field, another structure from what Descartes thought. And finally, another Nobel laureate, Roger Sperry, believed what most reductionist neuroscientists believe, that the brain generates the mind, and that's the story, and the chore is to figure out how that works. So 50 years later, the Vatican said, well, we better have another meeting on this. And so they did, and I was able to take part in that. And the upshot is that there's been a ton of work suggesting that there is this neural network being studied, and if we can figure out the logic of the network, we will be able to understand what conscious experience really is. And these are various players, everybody from Francis Crick to Jerry Edelman, Giulio Tononi, Christophe Koch, Stan DeHaan, Bernard Bars, and so forth. These are the modern students. And they come back to this model that there is a network in the brain. Somehow it interacts in a way we don't quite understand yet to produce what you think is your own personal conscious experience. Now, I have a different idea, a little different hunch. And I think that, in fact, the brain is loaded with millions of local processing units, each one capable itself of generating what we will come to call a conscious experience. And instead of just saying that, I have to provide you some evidence. So what I've done over the last years is study split brain patients. These are humans, obviously, who've had their brains divided in an effort to control epilepsy, by the idea simply being that if the seizure starts in one hemisphere, it won't travel to the other because you've broken the connection between them. And so these split brain patients have given hundreds and hundreds of experiments that have revealed a very different picture. So can consciousness be divided? Simple question. Do you think, as you're sitting there, that a surgeon could go in and tickle parts of your neurons and you could get two of yourselves inside one head? And the answer, of course, is yes, we know that now. That happens. And the real question is, how does that work? So separating the two pictures, the two hemispheres, right brain from left brain, all of a sudden you have two conscious systems. Well, if it's a general network generating consciousness, how could that be? That challenges that idea. And I don't think this video works, but this was a video.
Show me with your...
Yeah, no, never mind. It's a video demonstrating one of the patients who could be doing something with one hand and the other side of the body wouldn't know about it, didn't understand it, and so forth. So one of the most amazing aspects of this is that, in fact, when a split brain patient wakes up from surgery, and this is now a person who can only explain stuff to the right of, fixate a point, they can only explain information to the right of where they fixate and not to the left, you would think, you would note that. You would think, say, doctor, I can only describe things over here. The patients don't. It's like one hemisphere doesn't miss being in touch with the other hemisphere. And so how you can explain that is that the processes that generate consciousness of a capacity are very localized to the capacity itself. Now, here's the rule that comes out of all that. Consciousness, in fact, can be subdivided again and again. At every level of the brain, consciousness arises from local circuits, for local circuits, not a central program. The very, very definite prediction. And so you come up with the view that when you and I are sitting in a moment, maybe we should have more of the bubbling water idea. These little modules, these little circuits, one of them comes up, and at that moment, that is what underlies your conscious experience. And you say, yes, but then how could that possibly explain our sense of continuity and psychological reality? Well, Sir Charles Charrington in 1939 noticed, is the mind a collection of quasi-independent perceptual minds integrated psychically in large means by the temporal concurrent of experience? Its separate reserves of subperceptual and perception brain, if we so to speak, can account for the slightness of impairments, of the destruction of the clothes. He predicted our results. So what he says, what happens, and raises the question, how these bubbles, when they come up, our sense of consciousness and experience is through time, just contemporaneity of time. We see it as a unified whole, when in fact it's a series of these individual events occurring. Now finally, how do we get from that model to the notion of self-identity? How do we generate self-identity? Well, one of those modules we discovered in our research is a system, it's only in your left brain. And what it is it tries to explain yourself to yourself. It tries to explain your behavior. And so how we showed this was we would put patients in front of this little machine, and and their task was for each hemisphere to point to a picture that matched the picture that it saw. So if you put something to the right of fixation, the picture of the chicken claw, that goes to the left brain. And that left brain controls the right hand, and so the correct answer is to point to the chicken. The left visual field stimulus goes to the right brain controls the left hand, and there the correct answer would be to pick the shovel to go with the snow scene. But split brain patients only talk out of one hemisphere. They only talk out of the left hemisphere. So the left hemisphere doesn't actually really know why that hand is pointing to the shovel. And so that sets the stage for the obvious question to the patient: why did you do that? Why are you pointing the way you are? And the patient says simply and clearly, oh, that's easy. The chicken claw goes with the chicken, and you need a shovel to clean out the chicken shed. So it interprets the behaviors that come from the person and the body and builds it into a story. And it is those stories that sustain us and become our self-identity. So we wind up then with this view. Are we automated? Determined? Well, we're not. We know clocks are automated. They wouldn't work otherwise. We also know that every cell in your body is automated. It's a little machine working away. So why are we so upset that the brain may be an automatic machine? And people are upset because that makes it think like you're not willfully carrying out your activities. Well, that's not true. That's not how you think about it. Responsibility doesn't come from the brain. It comes from the social contract you make with other people. If you were the only person in the world, there's no concept of personal responsibility, right? There's nobody there to be responsible to. Put one more person in the world, and all of a sudden you're going to have rules. So we're faced with the situation that even though our brain is mechanical as clockwork, we enjoy a richer opportunity and story by simply interpreting a greater and greater amount of information, and are held responsible because of the rules we chose to live in the society, in a society. So not so bleak stuff in the social layer. Responsibility rises out of people, not brains. And you're going to hear a lot more about it when that book comes out. Thank you very much.
velocità fino a 110.000 giri al minuto, il motore digitale Dyson è il cuore del nuovo concetto di asciugacapelli. È più veloce e leggero rispetto ad altri motori che appesantiscono la testa degli asciugacapelli tradizionali. Il motore è integrato nel manico. Il microprocessore monitora la temperatura dell'aria 20 volte al secondo per prevenire i danni dovuti al calore eccessivo e proteggere la naturale luminosità dei capelli. Dyson Supersonic.
Che è? Eccomi. Eccomi. Vi conoscevate, eh? Sì, però io ho fatto già 2 gaffe in un minuto. Ah sì? Sì, sì.